whether the block will slide or not. So look at, there are two forces. F1, how the force F1 will act? Normal to the wall. What about F2? Will act tangential to the wall. If you are getting confusion, the best thing is, what about F2? F2 I can't show in this diagram, second diagram. Here I will give in this direction. F1 is equal to minus 10 I cap mg is equal to 20 the weight, then F2 is equal to 4 k cap. Hope, yeah, are you able to understand now? There's a wall. The plane diagram is this one. How the force F1 x normal to wall, F2 x on the block parallel to the wall. Force F2 x on the block okay, in the books they are given question. I'm just breaking up. Okay, fine. Now it's asking whether the block will slide or not. If you draw there's a wall. See, there are so many ways there you can imagine. Like, just you are facing the wall. Normally you are looking at the wall. Then what you see the block here. That's all, no? You see the block mg. Then you see the force F2 acting like this. What about F1? F1 you are applying into the plane. And what about normal reaction? Normal reaction will be out of the plane. I think everyone knows this symbol. Into the plane.
Yes.
Out of the plane. Then how the friction should act? How the friction should act? Shall we take upward? If only select, if this F2 were not there, how the friction would have been upward. Here. Agreed? Then if this F1 were not there, then because of F2, the friction would have been like this. Because of now the weight mg and F2, so the friction will act certain angle here now. Another force will act parallel to the wall. This F1 will act normal to the wall. F2 will act on the block parallel to the wall. They don't give any of the diagram. They just explain. You must know all these things. So just take one box, press against the wall. One force you are applying normal to the wall. Other force from the side. Here. You're applying. So the friction will act. The block is having tendency to move like this here now. Therefore the friction will act here. Now let's go for one by one. N minus F1 equal to 0. Then what is the maximum limiting friction? Limiting friction will be FL equal to mu n. Mu is how much given? 0.3. F1 is how much? 10 Newton. 3 Newton is what? Limiting friction. We'll calculate the frictional force now acting. I'm assuming that the block will be at rest. I'll calculate the friction. Friction less than limiting, slipping will occur. The friction force acting is less than limiting, it will be at rest equilibrium. If the friction force acting is greater than limiting, then it will slide. Then along y-axis, sorry, along x-axis, f cos theta. Okay, keep it here. What is F2? F2 is 4 Newton. Then along y-axis, mg minus f sine theta equals 0, or f sine theta minus mg equals 0. So do we know theta? No, we don't know the theta also. Mass of the block 2 into 10. So 20 Newton it is. So we'll square f cos theta equal to 4. F sine theta equal to 20. We'll square and add them. (16 plus 400). 416 must be greater than 20 Newton. But what is the limiting friction? Just 3 Newton, no? So what do we expect? F greater than FL. So what will happen to block? Block slides along the wall. Okay, like this is what the questions are there. You should be able to make a guess of direction of friction. You should not show like this, component of friction. Yeah, don't write F1, F2. The resultant friction at certain angle, then you solve it. So this parallel to the wall, please do understand, very important. Somewhere I shown here XYZ axis. Make observation, we'll take the